Okay, so I'm sharing my whole screen with you all here. Okay, I tried to make this as big as I could. Okay, so this is my terminal. I've logged on to Perlmutter. And then the first thing we're supposed to do is CD to Scratch. All right, this is my Scratch directory. I think I don't know that anything is left in that directory, but I'm just gonna delete it anyway. Okay, so what am I gonna do? I'm going to do the git clone thing. Let me look at that. Here, git clone. Okay, you can also find that in this Q&A doc. You can find it right here. Yep. Great. So now I have this directory, Crash Course Supercomputing. Okay, so what I want to do is I'm going to copy this one right here. And I'm going to copy this one to just Scratch. I'm just going to copy it here to my home, like my Scratch directory. Copy. Okay, and then I have it here. So darts.c is right here. So if I can edit it, you can see here it is. Okay, if I want to compile it, I'm going to use the built-in compiler wrapper that's called CC in order to compile it. So I'm going to do CC darts.c. And that has generated this file here called a.out. Okay, if I wanted to, I can, of course, name it something better when I do this. So if I do CC minus O, oh, sorry, CC darts.c, so darts serial. Okay, so Huiyan, to address your question, you would need to make first before you do the run all. You'd have to make all of the files. That's why it's not finding them. Okay, so let me share my screen and we will get started. Okay, so I have copied my darts.c into a new file called darts-mbi.c, but I haven't done anything to it yet because we're going to talk about how to do this. So first, let me just do this. Okay. Now, in order to do this, we're going to need to include mpi.h, right? Because we're going to need those header files for MPI.
Use MPI in your for C. Yeah.
Yeah,
For C is still.
Yeah, okay.
China's use MPI. Sorry.
Yeah, for China to use MPI. Yeah, for C though, it's pound include MPI.h. I think actually you can maybe do just pound include MPI and not the .h. But anyway, in any case, it'll find it this way. Okay, so remember when we talked about PCAM? What do we need to do that is parallel, and what do we need to do that is serial? Anybody remember? or have a suggestion? Somebody has something in chat, Mary? Count darts and measure where they land is parallel. Yes, good. Thank you, Zachary. Okay, so this is the part that we're going to parallelize, is whatever's going on in this loop, right? So when we're using MPI, we want to put our MPI init after our variable declarations and before we do anything MPI. So, oops. Let's do it that way. So we're going to do MPI init. That's where our MPI init goes. And then our MPI finalize is going to go right before this return 0. MPI finalize goes there. Okay, so if we just ran this code the way I have it right here, right now, what it would do is it would just run n different implementations of the same thing, and it would print out computing pi and serial n times for n processes. Okay. So, but it still, we have a parallel code now. Okay, so there's a few things that we're going to need. So one thing is we need to know what rank we are and the size of the MPI communicator. So I'm going to make some variables for that. And rank and size. So let's call this me and just because that's what I've kind of called it before in other things that you've seen. So those are going to be things that we're going to need to figure out. There's another one that we're going to need, which is MPI status. Remember, when we're receiving, we need to have an MPI status. So we'll just go ahead and define that. That's all I can think of, but we can always come back up here and create new things. Okay. Somebody else have an idea? Step in a loop can be considered one unit to be parallel. That is true. Very good. Okay, so what are we gonna do? We're gonna do, we gotta divide up the number of trials, right? We have to divide it up evenly amongst all of our different MPI processes. And then we'll have each of them do this, and then we'll have them send, right? So really, we probably need another variable for the individual number of trials that each one of us is gonna be doing. Let me add that along my trials. And then, yeah, that's probably the only other one we need. We'll find out. Okay, so how are we going to compute this? So first we got to do MPI size. Okay, another thing that's good. Hold on. Another thing that's good manners for us to do, which I probably didn't do before, is MPI is to set our MPI communicator. So this way we won't accidentally do something to MPI comp world. So equals MPI world. So then we're finding the size of the with the communicator com, and then we're putting that into MP. Okay, so then from that, we can figure out the number of trials. So my num, if I can type properly, num trials equals num trials divided by MP. All right, everybody think that ought to work fine? What if I have a million trials, I have 3 MPI processes. Is that gonna work? No, everyone is going to do 333,333. And if you multiply that by 3, you get 999,999. Maybe that doesn't really matter in the larger scheme of things, but it could, so we need to fix it. So we need to set my num trials, so somebody needs to do that one extra, right? Somebody have an idea here? Oh, is it possible to turn on line numbers? Sure, okay, I will turn on line numbers, thank you. Sure, I can do that. Let me just save because I'm paranoid. Set number. There we go. Okay, thank you. That's a good idea. Thank you, everyone. Okay, so here's the thing, right? I'm gonna need to make some kind of an if statement that is going to make sure that I get the right number here. So I think if I do this, so if my rank, if me is less than num underscore trials, not trails, trials, modulo MP. And then my num trials plus. Okay, so what I'm saying is if we have 3 processes and we need to have one of them do extra. So then we can just have processor 0 do extra. They'll just do 1 extra. So then if we had something where the modulo turned out to be 2, right? Then we would have 0 and 1, they would take on 1 extra dart throw. Now, because these dart throws are pretty trivial, it's totally fine to do this. If they were not trivial, then you would have to figure out a different way to load balance it. You would probably want to put those onto the last process instead of the manager process. But in this case, it's pretty trivial, so it probably doesn't matter that much. Okay, so then for all of our processes, we are going to come down here and we are going to good. We are going to come down here and we are going to change this to my num trials, right? My num trials, because I'm just doing the number that I need to do. I'm gonna make my X and Y. I'm going to see if they are in there, and then I'm done with that part. So then what else do we need to do? So we need to either send our stuff to the manager, or we need to be the manager and receive everybody's stuff, right? Okay. So let's do that. If me is, let's say, not equal to 0, Then I'm gonna send my stuff. Okay, let me just put a little send my stuff. And then I'm gonna do. Oh, shoot. Let's with that. Okay, I'm gonna send my stuff. Otherwise, else, I am going to. Sorry, I'm going to receive stuff, then compute pi and print it out, right? So my end of this else actually comes down to here. Do it like that. Okay, so let's talk about sending. So I want to send my stuff, right? When I do that. Okay, so I'm gonna send my stuff. How do I send? I'm doing MPI send. And I'm sending my number in the circle, so N circ. There's one of them. Okay, and I have that ampersand because again, I'm giving it the address where this thing is stored, not the actual value of it, right? There's one of them. It is an MPI long. I am sending it to 0. I'll just send it myself as my rank as the special tag. And let's see if I got that right. So I don't, never easy to remember things. So I'm gonna look here because cheat off of my own code. Okay, here's, oh no, that's not the right one. So sending whatever it is, sending it, yep. Okay, I think I got that right. So I'm sending it to 0. Now, if I am 0, I need to receive, but where do I need to receive from? Well, I need to receive, oops. I need to receive from all of the other processes. So I need to receive from 1, 2, 3, 4, etc. up to n-1. So I need a loop in order to do that, right? If, oh, not if, for, see, what have I not used yet? Int, say j equals 1. And the reason I'm doing 1 is because I'm not going to receive from myself. I'm just going to receive from everyone else. J is less than NP. J less plus. MPI receive. Oh dear, I need a place to put it in. I don't want to overwrite my own ncirc, right? So I'm going to call it a temp, and I will create that variable. Don't let me forget. MPI long. We're going to be receiving from J. The tag is J, and then that's our communicator. And okay. I'm going to create my variable temp long TMP. Okay. So I have received that. Oh. And then I'm going to add it to the NSERC. NSERC. Okay, this is a cool C thing plus equals TMP. That should be the end of my, yes, that's the end of my for loop there. Okay, so let's see, is that all I need? Does anybody see anything I might be missing? Anybody? It all looks great. Oh, okay, we've got some comments in the chat, maybe. My random number generator is broken. Tell me about that, Ron. Yes, tell me about what you're talking about here. Good. Can we just use the, let's see, Sophie. We just use if b equals 0. Let him trust equals. No, because, oh, I see what you're saying. Yes, we could, but then the thing is that then, that process is, okay. No, you all don't see this on there. Okay, can we just use if b equals 0? Let me put this in a. Sophie, did you put this in the doc with the questions? Would you mind doing that if you haven't? So the thing that you're proposing there, Sophie, is going to give processor 0 all of the extras. And we want to kind of round robin those extras if we can. Because what you're proposing is like if, let's say we have a number that is a number of processes that is prime compared to 1,000,000, right? Then we're going to have that number minus 1 extra work to do. Okay, so let's say I could pick a very large prime number, but I'm just going to pick 11 because it's easy. And so we're going to have 10 extra, right? No, we're going to have, I don't know, we're going to have extras. We're going to have like almost 11 extras. And so that's not going to really work. Oh, status. Lori. Let's see. Oh, I need the status at the end of receive. Thank you all. Thank you. Thank you for catching that. You are correct. I need status. Okay, thank you. And then let's see. Young Rock, I do have finalized. I put it in at the very beginning so I wouldn't forget. Okay. Unique random seed. Okay, Ron, yes, you are right. This is gonna run, but what we're gonna get is we're gonna get actually really poor results. And the reason is because that random number generator, it starts with a given seed and it goes through the sequence based on what that seed is. And so they're all gonna start at the same point. So it's gonna be repeating the same random numbers over and over again. And so it's just going to be a repetition. And so thank you for pointing that out, Ron. I didn't expect anybody to point that out yet, but good job. Thank you. So let me go ahead and just see if this is going to compile. Because I'm crazy like that. So I'm going to cc darts-npi. See, I'm going to make it. Sorry. We'll just see if it's going to even work. Oh, no. Okay, I knew that was wrong. It's MPI communicator is actually, I think it's just MPI com. Let me see if it will compile. Yeah, okay, so it compiled, right? Okay, so it's gonna run, but now I need to get into my interactive job, so I'm gonna salloc n1 minus capital C CPU minus reservation equals crash course minus a trn 012. And then my time, I'm gonna put 30 minutes, let's say. Okay, great. Okay, so now if I run this, because we're gonna show why Ron was right. Why this is not going to work. So if I do srun minus n1 darts dash npi. Okay, so I'm running it with one process. Okay, so this is what I get for my million trials. I get pi is 3.141648. That's not too bad. Okay, so now I'm gonna run it with 2. Okay, 3.1417. Okay, we're getting off, aren't we? This isn't as good. If I run it for, let's do 4. 3.1406. Okay, we're getting even worse off, aren't we? Yeah, look, we're getting like farther and farther away from actual pi. And the reason is because effectively, if we're running with 8 parallel processes, then we are reproducing the same sequence that is an eighth of the original sequence 8 times. So that's the problem. So Ron was absolutely correct. So let me go in here and let us, oh, wow, we're getting to some exciting stuff here. Let me via my darts dash MPI see here and right, so how am I going to fix this? Well, what I need to do is I need to change that seed for each process. So what would be a unique thing that I could use to create a unique seed for each process? It's rank, yes. Very good. So how do I do that? Where's my seed? So if we go to LC generator here, we can see this is the seed right here, random last. So we because this is like kind of a strange, you know, these are effectively like global variables. So I can just change random last inside of my own code. So again, I can just do it right here. Random last is equal to me. Okay. All right, so now let me recompile. And let me try these again. Okay, we got 3.141648. We've got 3.142076. Let's try 4. Okay, so, you know, let me just state that there are other flaws with this. So we're not going to necessarily get a better result from using from these different number of parallel processes because if you looked at lcgenerator.h, so let me show you that again. if you look at lcgenerator.h, this number right here, p mod, that is the length of the period effectively of this random number sequence. So it only has 714,025 in the length of the sequence. And we're doing 1,000,000 dart throws. So there's some overlap. And then furthermore, if I'm starting in one place, someone else is starting in another place, there's going to be an overlap of some of our numbers that we're using. There just probably will be. So that's just something to keep in mind. Okay, so does anybody have any questions on this one? And if not, we can move on. We've got about 2 minutes to do the collectives, but actually it's going to be a lot easier than this one. Any questions so far? Otherwise, I'll move on to the collectives. Okay, we will move on to Dart's collective. Okay, so set numbers. Oh, not numbers, what was it? Line numbers. Always forget. What did I do? Somebody put this in the. Nice. Okay, thank you for saving my bacon. Set number, not numbers. Okay, thank you. Okay, so if we're gonna do this with oh, even better. Okay, we're gonna do collectives. Okay, does anybody remember which collective that we're gonna want to use? Anybody remember that? So, you know, we can look at the collectives, I suppose. We can kind of review the ones that we learned, but they are, we've got, let's see. Okay, here's the list. Broadcast, do we want to broadcast? No, probably not. Do we want to gather? Almost, right? Because we want to get all of those numbers and bring them into one centralized location. We don't want to scatter because that would be opposite. But really what we want to do is we want to reduce. Okay, that's really the one that we want to use. Right, because if you recall, reduce, you're using a particular operator. Sorry, an operation like sum. Right, which is the one thing that we're doing. We're summing up all of the the values of n in circ. So let's do this really fast. I realize we're into lunchtime right now, so that's why I'm going to do it extremely quickly. Okay, so basically this whole part here, if I'm not equal to 0, that's gone. Right, there's actually nothing that we're going to be doing here. Nothing special here. Okay, I probably should rewrite this okay, but then otherwise, if I am doing this on process 0, then I am going to, I don't need this anymore. I don't need to have that going on there. But what I do need is I need to do this reduction. Okay, so what I'm going to do is I'm going to put up here before any of this specialization of tasks, I'm going to put MPI reduce. And I'm gonna put, so the location of the thing that we're reducing is in circ. Okay, I don't remember the format for reduce as well as I should. So let me put this here. Oh, okay, then we need the buffer that it's gonna be received into. Okay, that's gonna be temp, and you have to remind me to add the temp here. Oh, sorry. And we're going to. Okay, the count, that's gonna be 1, this is gonna be MPI long. And then it's gonna be reduce root, okay. Let me see if I can get this here better.
Is there a barrier in this reduce call or,
Yes, reduce by nature is gonna have a barrier in it.
okay,
That's a great question. See if I can just get this all lined up correctly. We receive both, okay, count is 1. MPI data type is next. So MPI long. Okay, and then the operation is, we learned here, it is MPI sum. MPI sum. And then the root is gonna be 0. And the communicator is com. Okay, and so we needed to have defined that temp variable, so I'm just gonna put it up here at the top. Okay. And then in here, we're gonna say, so when we're processor 0, and we're gonna say that ncirc, we're gonna set that equal to TMP, right? Because we've gathered everything into it, so that's our new ncirc. And then we're gonna compute pi, and I think it should work. Did anybody see something I missed or that I left out? Okay. You know, just to make a comment here, I could have just changed this whole thing to if v equals 0, right? I could have done that, but I'm in a hurry, so I didn't do that. Okay, so now let me just CC this thing. CC, okay, we're doing collective. Right. All right, now let's run it. So I think we should actually probably get the exact same answers that we got here. Yeah, 3.141648. Yes, I think these are the same numbers, aren't they? Yep, they're exactly the same numbers, so that's good. We're at least we're consistent. 3.1408, yep, and 8. Great. Okay, we did it.